Hey guys, I thought I might do a recording and upload it to YouTube about what I was trying to get to at the end of lecture today, which is about actually using finding the solution to a least squares problem and actually fitting it to data. And so what we have here is this little example I prepared, which is basically five ordered pairs that pretty obviously don't line up in a line, but yet what we're trying to do is come up with some sort of a regression, linear regression through there. It's a best fit equation for the data points, so that we can actually create a linear model for the data, and it's done all the time. Well, what we learned last time, well, this earlier today, was if you are trying to solve ax equals b, but B is not in the column space of A, then our next option is to solve AX hat equals B hat, which is it's the closest approximation where B is the projection of the vector B onto the column space of A. We came up with a formula this morning that said, finally, A transpose A x hat is equal to A transpose B, which actually turns it into a linear equation. Now, how does this fit the graph on the left here? Well, what we're trying to do is find a mega linear equation, y equals mx plus b, that fits the data. So it has to be that it fits every piece of the data. So that is to say, if I go one by one with these data, when I plug in a 1, I should get that's supposed to be a 4. Okay, when I plug in a 2, also 4. When I plug in 3, I get a 6, let's say, according to the data. When I plug in a 4, a 7, and 5, you should get a 9. And so what I tried to do is graph it really roughly up at the top. But what this means is that if we multiply by some unknown slope and we add some unknown intercept b to get 4, what we want is an equation that satisfies every single one of these guys. So m times x plus b equals y, and down the line. M times 4 plus whatever b is equal to 7. And what we know, I think, by just looking at the picture, or what we know about lines, is that is a system of equations with no solution, okay? So, but what we can do, this is what I was writing before we left, was this is the same thing as taking a matrix. This is at the beginning of our course, and you go, well, okay, what I'm going to do is I'm going to take 1m and 1b. I'm going to multiply it by the vector mb, and on the other side is the result that I'm seeking is 4. So that first row times that column, that vector mb, is saying 1m plus 1b equals 4. And now you see the pattern, 2, 1. I'm counting the coefficients of m and b, okay? 3, 1, 4, 1, 5, 1. And we want them to get to 4, 4, 6, 7, and 9, okay? So playing the role of A in this formula is this guy. Playing the role of B is this guy, okay? So to solve it then, we'll use this formula, okay? Ooh, it looks like I got some stuff I gotta clear off there at the bottom, okay. All right, so what we have to do then is we're going to run it through A transpose A times our unknown x hat, I'm calling for this vector, is equal to B, okay? Oh, I'm sorry, is equal to A transpose B. Okay, so I took the liberty of doing the math, the calculations, so this is faster. But really what you're doing is you're going to transpose A. So the first column becomes the first row. Second. And it multiplies with A itself. nifty way of doing this, times x, right, hat, is equal to A again, oh, A transpose again, times B. And this would be a homework problem in section 6.6. Using this to come up with the least squares and to erase as we go. Okay. So I took the liberty of multiplying this stuff out together, and what I got on this side when I multiplied all that together was 55, 15, 15, 5. No surprise, because look, this is a 2 by 5, this is a 5 by 2, so we get a 2 by 2. This is a 2 by 5 times a 5 by 1, so we're going to get a 2 by 1 here. Okay, so we have times x hat is equal to, and this vector on this side ended up being 103 and 30. Okay, and then it's a matter of solving that system, and you will find your solution. Yeah, we must be looking at some calculus 2 here at the end of the semester, right? So we'll try. This is so low budge. Anyway, so what I did to solve this guy was I just took this guy's inverse on the other side, and it ended up being 1/50th. Just to see the numbers, it makes it real, you know. 1/50th and then 5/55, switch places. Change the signs as usual. For the inverse of a 2 by 2 times 103 and 30. You do all that math, and I won't bore you with all the sweaty details, but what we end up with is the numbers. Let's see what I got. 1.3 and 2.7. Okay. So what does that mean? We're done. This is the vector MB, right? So our equation, there's the application, is y equals 1.3x plus 2.7 is the best fit linear regression model. It was precisely in that class I took last semester where I saw this formula but written with different letters or whatever, and so there you go. Yeah, so if you take that equation up there, it should be the one that fits right there. Okay, so I wanted to share that with you. Hope you enjoy it, and that's how you do the homework in section 6.6, but 6.5, a little more straightforward, just having you find those things. Okay, that's about it. Hope you enjoy it.